Now question 3, a question on the applications of number patterns. So lana we are given a structure that looks like a cylinder stacked on top of each other, right? To me it looks like a game called the Towers of Hanoi. It's a mathematical game. Just check it out. Okay, so the description box is a tolama links for other recordings for this question paper. Now question 3, uthi a sightseeing point is built by placing concrete cylinders with a height of 0.2 meters on top of another. So I'm staking a cylinder on top of each other. The thickness or the height of that cylinder is 0.2. The radius of each consecutive cylinder is 4/5 of the previous cylinder. So to get a radius for a cylinder, I would have to take the radius of the previous one, you multiply of 4/5. Bese basipha ne radius of the first cylinder, the one at the bottom, 15 meters. 3.1. John is standing on the 17th cylinder. Calculate John's height above the ground. So lago 3.1 sizoti height above the ground for, okay, 1 mark, height above the ground, maybe singathi yela ground is equal to 17. John is standing on the 17th cylinder. We're gonna multiply 17 by 0.2. We want his height above the ground. Since all the cylinders have a consistent height, 0.2, I've only counted 1, 2, 3 cylinders, but John is standing on the 17th, so we have to multiply by 17 to get the height. So they are stacked. So we're gonna multiply by 17 lo 0.2. 0.2 answer 3.4. So 3.4 meters is the height. 3.4 is actually what? The height of John above the ground. Okay, 3.2 siningi challenge gela. But it calculate the volume of the 17th cylinder. Now John amekhona on that cylinder John is standing on. But it calculator the volume. How do we calculate? Volume la. Okay, I just realized my volume is off la. But anyway, 3.2. So the volume of a cylinder is calculated as pi r squared multiplied by the height. This is the formula for finding a volume of a cylinder. Alright, so Tina, what we're gonna do is get the volume. I do have pi. Pi is just 3.142, right? We are told to calculate that value. I also have the height for the cylinder, the 17th cylinder. The 17th cylinder has a height of 0.2. It's constant. The height is consistent throughout, right? Every cylinder has the same height. Now, the problem is here. Radius. What is the radius? What is the radius of the 17th cylinder? Okay, 17th cylinder. There is a pattern in terms of the radius of lama cylinder wethu la. Yeah, it has to do nalo 4/5. So let's check radius number 1. Okay, let me just say radius number 1. Radius number 1 has a radius of what? Cylinder number 1. Let's just say cylinder number 1. Radius for cylinder number 1, it's what? It's 15. Radius for cylinder number 2, it's what? It's 15 multiplied by 4/5. As per instruction, according to that statement, it's 15 times 4/5. That's radius number 2, right? Radius for the second cylinder. Radius for the third cylinder, it's what? It's 15 times 4 over 5 times another 4 over 5, right? The radius of each consecutive cylinder elandelayo, radius corner, it's going to be 4 over 5. So every time I take the previous radius, the radius for the previous cylinder, and multiply with 4 over 5. So for the third one, goes about 15 times 4 over 5. So this is going to be squared. 15 times 4 over 5 times 4 over 5. So it's 15, 4 over 5, everything squared. Okay, everything squared. What about the fourth one? The fourth one is this. 15 4 over 5 what squared multiplied by umunyu 4 over 5. So the answer la yoba ubani 15 4 over 5. Do I have to keep on going and show you all the radiuses or amaradi for each cylinder? No, I don't have to do that. I don't have to do that. But I'm not sure to a pattern la ukuthi for every radius, right? For example, radius number 4, the exponent la we subtract it by 1. We are subtracting it by 1, and then we put 4 over 5 in brackets and raise it to this exponent and multiply by 1 by 15. So for radius number 17, it's gonna be 15 4 over 5 raised to exponent by 16. This is the radius, right? Okay, ungayicalculator so by just observing the pattern between the exponent and the position number of of your cylinder. Cylinder number 2, exponent it's 1. Cylinder number 3, exponent is what? Is 2. Cylinder number 4, exponent it's what? It's 3. Cylinder number 17, it's gonna be 16. You can do that, or you can just stop lagupi on the third or the second term, right? Third and second term. For the fact that you are multiplying by 4 over 5 every single time to get the radius of the subsequent or the following cylinder, the radius of the following cylinder, you have a quadratic pattern, right? You can take A wako. You can also calculate R wako, right? The A in this case it's A, it's 15, and then your R utata the second term, we divide by the first term. Then you have the 15 cancels the 15. I have 4 over 5 as my common ratio. Then we are 7 what? Right, the answer is totally 9. I'm just showing an alternative of doing this. Yeah? Showing you an alternative of doing this. You can just go ahead and then uti, okay, my Tn A uzo 7 inside this formula again, -1. It's basically the same thing. You're gonna end up here now. So having the radius for the 17th cylinder, you can now substitute lapha and calculate the volume yakho. And calculate the volume yakho. Just to make abanye bantwana happy, let's do it anyway. Let's use this one. So Tn, I'm looking for the 17th term, radius here. No, not radius. Constant ratio. It's gonna be the 4 over 5, and then n, it's 17. So 17 minus 1, that's 16. I end up at the same point. That is my radius. Radius here. Now I wanna calculate the volume. Pi radius, the radius it's this value. Radius for the cylinder number 17, it's 15 4 over 5 raised to exponent 16 squared. What is the height? To 0.2. 2. So the volume is equal to, see calculator, so it's shift pi, open bracket 15, open bracket 4 over 5, close bracket 16, close bracket squared, multiplied by 0.2, 0.11 in 2 decimal places, 0.11 meter squared. Yes, meters, no, meter, cubic meters. It's volume, cubic meters. So now I answer it together. Now I answer it. So for the last one, for 3.3, they want us to calculate the volume of concrete that will be used to fill the first 17 cylinders. Okay, we contractor, you are constructing this thing, right? You are constructing this structure. Okay, so come look pour concrete for every cylinder, starting from the bottom going all the way up to the 17th one. So to work out a volume also a pour or also a caster into these cylinders, come the volume for the first cylinder, second cylinder, third, fourth, 15, 16, 17. Then you are add all of them. Keyword, add. So we're gonna have to add all the volumes from 1 all the way up to volume number 17. So it's a sum problem. It's basically a sum problem. So what do we have to do, Lana? We have to find volume number 1, volume number 2, volume number 3, and see what is there a pattern a corner, which there is. Just thinking about it, I can see there is a pattern, but asiko sure it's arithmetic or geometric, but we'll find out. But another prediction against it's gonna be a geometric one. However, we multiplied by a constant ratio, like 4 over 5 for the radius. The height is constant, but the only changing factor, like it's the radius, right? It's the radius. So mind we have to add all lama volume all the way up to the 17th. So ngizothola the volume for the first cylinder. I'm gonna call it V1. Why call formula it? So volume is pi r squared times the height. Okay, so volume number 1 kuzoba lo pi. What is the first radius? So 15 squared. Height is 0.2 equal to, let's do this one. So 15 squared multiplied by 0.2, 45. So I don't have to multiply pi because I'm gonna get a decimal. So let's just leave pi as is. It's a constant anyway, so don't worry too much. Then we're gonna have another pi, open bracket, radius. So the second radius is what? It's 15 times 4 over 5. So it's 15, open bracket 4 over 5. That's the radius. We're gonna have to take the radius, square. We take the radius and square it. Multiply it by 0.2. Would it be a good idea to multiply this one? I don't know. Let's check it out. 15. If I get a crazy number, I'm just gonna leave it as is. So 15. Okay, ngidinga bracket la. I'm not multiplying by the pi, by the way. Ne? So I just want to check, do I get any crazy number la? If yes, we're gonna leave it as is. Close this bracket, then multiply by 0.2. Okay, no problem. So it's gonna be 1 144 over 5 nazo. Then v3, we're gonna do the same thing of v3. So the pi open bracket 15 4 over 5 squared close bracket squared 0.2. Remember the changing thing, the changing variable, it's this one, it's the radius. It's the radius, that's what's getting affected. So the height remains constant, but just make sure you pay attention to your radius. On the previous question we did do or did work out ama radius weight, right? So lana we're gonna do the same. I think but this time I'm putting it in ubani with 3. No, it's gonna be squared, still squared, but this time lana I also have a squared inside the bracket. Wow, this is what I was avoiding. Okay, 2304. So stop volume number 3 because I'm going to calculate all the volumes until volume number 17 basing our add. It's gonna take us a while if we do that. So manje. One thing for sure, this is going to be a geometric. It's definitely a geometric. So but we have to test constant ratio. So our ratio tata the second thing divided by the first, and also check the third volume and divide it by the second, just to check do I actually get a constant ratio. Okay, so volume number 2, 144 divided by 5, shift pi, but okay, anyway bazo cancelana labo pi, but asibabhale 45 shift pi, I'm getting 16 over 25. So 16 over 25, this is my constant ratio. But making us okay, don't make assumptions with no value correct. Just check also check with the next ratio if you do get to 16 over 5. So take t3 divided by t2 and see if you get the 16 over 25 as we did with t2 and t1. So lana is 144 divided by 5 equal to so yes, confirmed. This is equal to, the r is equal to 16 over 25. So we now have r, we also have a. This is gonna be our a value. So since it's a geometric series, we're gonna use this formula: a open bracket, then go about r not squared n minus 1. We want the sum of the first of the first 17 cylinders. So s n, it's gonna be 17. We are summing up all the way up to the 17th cylinder. Open bracket, open another bracket, put in your r, it's 16 over 25, and then n, it's 17 minus 1 divided by 16 over 25 minus 1. S17 is equal to, let's go, yay, 45 shift pi 16 over 25 close raised to 17 minus 1 vala, yay, 16, yay, 25, yay, minus 1, yeah when I'm getting a 39250 in 2 decimal places. 50 cubic meters, its volume. Okay, so this is the answer for 3.3. I hope you told some value out of this recording. Check out the description box for more content for this paper. Yeah, like, share, subscribe, if you like what you see. So for now, I'll spawn on the next recording. Bye bye.